Okay, go ahead.
Is this on? Yep. All right. Did I do it? No. All right. Hi, guys. Welcome. Thanks for coming. My name is Ivan Boyer, and I'm here with a colleague of mine, Jaime Franklin. Jaime Franklin. We're all part of Palo Alto Networks family, and today we're going to tell you about sort of our journey to automation. We're going to show you some use cases we found applicable to our journey, and then we're going to end up with a short demo about how does it all gel together. Before we start, can you show me with a show of hands maybe how many of you are familiar with Palo Alto Networks? Cool. And maybe, again, with a show of hands, how many of you are already using automation tools such as Ansible, Terraform, or something else? All right, about 50%. Excellent. Okay, so let's go on with it. So I think one thing which kind of escapes sometimes for the, some of you that are sort of new to the automation itself is that automation really must not require a programming experience. It must be easy. And the main reason for this is because, automation will help you get into the cloud, and it's going to be driven by your DevOps culture. And unless they understand it and can do it easily, they can't really evangelize your product. From our perspective, when we looked into this, when we tried the first attempts to do automation, they were really cumbersome and complex. And we had a hard time pushing our product to the cloud. However, when we streamlined into some of the tools I'm going to talk about, things kind of magically, the door opened and they started adopting our product in the cloud. So it must be easy. However, it's a balancing act. DevOps want it easy. DevOps is very dynamic. You got to put your VPCs in AWS, add, remove them. The workload lifecycle management is really much shorter than the on-prem. But the other side, security needs to be structured. Security follows very specific control change practices. The processes are well established. So it's really hard to find that balance between doing DevOps, automation, and security, especially for companies such as ours. As we jumped into the cloud, so for those that might not know, Palo Alto Networks started as the physical appliance and next generation security firewall. And then eventually, obviously, we figured out that we got to jump into the cloud wave. And as we jumped into the cloud wave, we figured out there are some major changes that are differentiators between the cloud and on-prem solutions. Cloud moves very quickly, obviously. You need to be able to instantiate your workloads, in a matter of minutes, if not seconds, if you can. The lifecycle management of the workloads is less than maybe a month or less than that. Containers, come up and down in 5 minutes or less than that. Very different than, a typical physical scenario where you plug in your appliance into a data center, configure it, plug in the network cable, and you don't touch it anymore until the next refresh cycle. So we very quickly figured out that the only way to get to this quickness is to really do it through automation. I'm going to talk more about it a little bit later with some details. Got to be reproducible, right? But we discovered that some of the customers that we deal with, they actually like to tear down their topologies almost on a monthly basis. They do this so that they make sure that the topologies are up to standards as far as security patches go, as far as the latest software goes, as far as pretty much all the patches are done. So they like to. Some of the companies actually do this weekly just to make sure that they're running the product on the most latest software. So again, if you want to reproduce something like that, if you want to deploy your solution into, say you have a QA staging area, say you have a production, say you have maybe your alpha staging area, you got to be able to reproduce that. And again, without automation, you can't do this. Got to be repeatable. Kind of follows the same example. You got to be scalable, right? You want to be able to auto-scale with the cloud and the speed of the cloud. Again, if you try to do this manually, there is no way you will catch up to the cloud ever. They're just going to run away from you. So fortunately, in Palo Alto Networks, we actually thought about this from pretty much day one. So we started in 2009 introducing the public API to all our products. This is XML-based API, which was, back in the days, that was, the next new thing which worked. But what we figured out very quickly is that some of the customers, that's kind of too low level for them. So, looking to the use cases and everything else, we figured out, okay, we got to jump onto something that's a little bit more higher abstraction than the API, and especially XML APIs are. So we, a couple of years later, developed a Python library, which is actually Python-driven CLI, which allows you to pretty much control most of the features of the firewall, very much like you would use the AWS CLI to control some of your accounts and VPCs and networking and everything else you can within the AWS. However, even that was too low level, and then we started looking into automation tools. And so as far as automation tools goes, we had to make a bet, because there was probably 50 of them floating around to figure out which one actually is going to be adopted the most. So back in 2015, we actually went with Ansible. That was before Ansible was part of the Red Hat, and it was a standalone company. And it seems like we made a good bet, because nowadays, it was configuration management tool back then. It still is, but it does much more than that. And it seems like actually the bet was okay, as Ansible seems to be predominant in some of the networking and security matters that at least we are dealing with. Again, as we developed, so what we did actually, we developed a set of the Ansible custom modules which allow you to control and configure our firewall, provision too if you need to. However, that covers only 70% of the use cases. Customer wanted more, so we came up with a SDK, Python SDK called Pen Device, which allowed to do even more. And then after that, since beginning of this year, we figured out that Terraform is something that lots of board in the cloud companies like to use, because it claims it's heterogeneous, it's easy to use in multiple clouds, all that good stuff. Which works or doesn't work sometimes. Anyhow, we decided to jump on Terraform bandwagon, and that was actually, so finally that clicked with a lot of our customers, because it seems like that was the right thing to do for the cloud. So what really happened is that we built a set of the tools in different levels and different abstractions to allow customers to plug in into any layer of this. Everything starts with our API, and if customer chooses so, they can actually go into the API, and directly interact with it. Lots of them like to use either our CLI tool or the SDK that we built around it. But then when you come to the DevOps, they don't really care about any of that stuff. They really care mainly about higher abstractions than that. And that's when something like Terraform or Ansible comes into play, as well as scripts, either your own custom-made scripts, CFTs, or even Lambda. We've seen recently that a lot of customers actually develop some of our tools in the Lambda itself using our SDK to talk to the firewall, because they really don't want to learn all the APIs, because they have a multi-vendor solution which they have to worry about. Okay, so that's the background. So let's talk a little bit about how does this cover some of the use cases. So Ansible has proven to be really good in configuration management. The way we use it is very different, and for those of you that actually know Ansible, you probably know that the way it works is usually through CLI, use SSH. What we needed it to do, we needed actually to talk to our XML APIs. So what we did, we created our custom Ansible modules that expose our functionality of the firewall, and you'll see in a second why that actually worked out just fine. And it allows you to describe interaction with the firewall through very simple playbooks. Playbooks is just a human-readable format that written in YAML that actually Ansible folks use in order to configure devices. Here we benefited from the fact that our APIs are very much identical, no matter whether you're using our physical device or virtual device, or even our central management glass of pane called Panorama. You can use the same modules against our APIs to control and manage these devices. So this is used very much for a configuration manager of the Palo Alto Networks devices. The next use case that we've seen adoption was in the public cloud deployment scenarios. So if you have ever tried, and I hope you did at least to see how it goes, to deploy your entire topology in AWS manually, you'll very quickly figure out there is a bunch of stuff you got to do. You got to instantiate your VPC, you have to create your regions, you got to create your subnets, you got to create your security groups, then you got to instantiate your workloads and hook them up all together, routing, everything else. In order to make this work, you have to talk to 3 different teams. You got to talk to app team, which understands workloads that you need to instantiate. You got to talk to the networking team, which is going to set up your networking the way it makes sense to them. And obviously, you got to talk to security team, who are the guys who will obviously look at this is all cautious security, which is almost impossible task, because usually those teams don't talk to each other anyway. So we figured out that if you show them that you can use the tools like Terraform and Ansible and have them actually create the snippets for each of these, so security team creates their snippet, they put in a Terraform, and the application team creates their own snippet, put them together, actually you can bring them to the same table, and things start moving much more quicker. So that was actually really helped us in a public cloud adoption. When we tried to push our firewalls into the public cloud and have them manually configure them, it was really tedious task. It was hard. This helped us a lot. Some of the companies are in this journey, cloud journey, stuck somewhere in the middle. Maybe because they're still trying to figure out the public cloud strategy. Maybe because this is something that works for them. Maybe that's maybe they're trying to scale up using the cloud with their on-prem, or whatever other reason. Maybe they don't trust cloud yet. Maybe they don't trust public cloud 100% yet. We can help these companies too. A couple of the partners that we're working with will actually use our Terraform Ansible scripts to actually create connectivity between AWS and their branch offices that they create or for scale purposes or otherwise, and our on-prem and their on-prem data centers by instantiating IPsec tunnels through something like AWS Direct Connect, IPsec tunnels basically, right? And they can use the same script to instantiate among all of their offices, which means it's identical, it's unique. If they need to change something within that IPsec tunnel, any configuration, the change requires one line change, and they can redeploy everything. Without this process will take sometimes months, especially for the companies that are geolocated all over the place. But now they can run one script, apply it to all these tunnels, and things magically happen. We also put a lot of attention to actually working directly with the cloud with our automation tools and natively actually integrating with the cloud. So an interesting example that we actually found that works very well is that in a cloud you would instantiate tens, hundreds, thousands of your workloads, tenfold at least from what you would do on just on-prem data center, and really to keep those workloads in check and making sure that they are all adhering to the right security policy is really painful. So what we did through our automation tools and native integration with AWS, we actually have an ability to query that metadata. And once you query that metadata gets pushed to the firewall, and it gets applied to the security rule. So as far as the security rules goes, you create only one security rule to make it like a clear example. I want to make sure that all my New York web servers can only route, say, web traffic, right? So you create with that one rule, and through automation you can say, okay, I want you to query metadata on AWS, metadata service, which I don't know if you guys are familiar with, and you can query that and push all the IPs into the firewall automatically. So you don't ever have to change your security rules. They'll get pushed when your workloads get deprovisioned. They will get removed from the firewall itself. So this is actually a very interesting and simple case which had a big traction with all our customers because they don't have to worry about now thousands of the VMs being instantiated by developers, by QA, by somebody else. They can create one security rule and just apply it to all these guys. And the last but not the least case is CICD automation. It's missing D. So as you create your CI/CD process and flow, and this is a typical process, it might be similar to what you guys do in your development. It might be different, but more or less it's probably 70% there. Most of the developers, and I come from development myself, they don't care about security. They just want to make sure that they can develop application, they want to be able to publish it, and they want to be done with it. So in order to make this work for them, you need to be able to actually plug yourself, a security company, into their CI/CD process. And things usually go like, a typical example is that you would have a GitHub repo or some repository, whatever you want to. You'll create an application, you will push some feature to the application, somebody approves the change, maybe it doesn't, maybe it's in staging area, and you're going to run your unit tests, whatever tests you have. One test passes, you're going to be deployed to production, And at this point, when it's in production, you got to call your security team and say, hey, can you please open port 80 for me because I just developed something. Of course, these guys will usually take a couple of weeks to figure this out, so it really doesn't work that way. You lose a lot of fluidity, you lose a lot of flexibility, and it's not dynamic, for any of these guys. However, what you can do with automation tools, what we've seen, you can actually plug anywhere in this, whatever makes sense for your workflow, in your process. You can plug, say, a basic Jenkins job, or TeamCity or any of that kind, which will actually look into the metadata of the application you're developing and push those security rules to the firewall. So they automatically will open up for you so you can test your application pretty much the same time when all your unit tests are being passed, the same time your unit tests pass. This is something that's actually interesting, and it's the whole concept of the security as a code. It's the whole concept of actually security that follows the application. And I've seen more and more companies doing something like this. Of course, again, like I said, security needs to be prescribed. Developers don't care about it. So how do you make everybody happy? Well, this is one way to make them happy, because your security team can set up the rules, which will come before or after your application developer rules, which will always make sure that your enterprise is protected. And developers itself can just decide to figure out, decide, if they need to test applications, they can, through metadata, pretty much expose it to our firewall. A simple example for those that use Docker, if you say that you want to expose port such and such, we can pick that up and push it in a firewall rule automatically. And now you can get to that instance immediately without waiting for somebody to approve the change. Okay. So I think on that note, I'll have my colleague take it over.
Sure. Thanks. Thanks. So as we look at, taking these tool sets, we've seen, I guess, as we take a step back and we look at customers, there's been this maturation process that we've seen with customers that I've been working with. So initially, getting started, how do you start working within the cloud? How do you start taking apps, moving them to the cloud? It became more of an education. We spent time doing a lot of education with customers. From there, we moved to talking about specific architectures. Once you understand the cloud, how the fabric of AWS works, how do I now build an architecture to be able to support my applications? From that, we've seen a move to then the automation pieces. So I'm starting to deploy applications now. How do I automate that? And that's where some of the tool sets that we're talking about come into play. From that automation step, now we're seeing customers that have a large cloud adoption. They're moving to that next level, and that next level is, how do I operationalize this? So as you look at that from the standpoint of now, I've got these applications out there. How do I manage that? How do I provide the environments for my development teams to be able to develop code? How do I move the process from developing that code to getting it into pre-production and into production? What are the methodologies that we have for that? How do I put this all together so that my SOC, my Security Operations Center, can take over these applications? So that last point that we've been seeing lately is customers that are now moving into that operational phase and trying to operationalize cloud. So as we look at that, something, as we said, that has to be simple and repeatable becomes very important. Something that will integrate security into the mechanism, into the fabric of what you're deploying, so that as you look at a developer, you can provide them the resources. And what I've seen is IT departments have really had to kind of become that AWS service provider or cloud service provider for their entire organization, and everybody's looking to them to be able to provide these environments. So we've worked with some customers where we've taken our automation tool sets and we're able to do something that's very easy, very repeatable, where we can take these tools, script a development environment, and then put some process around that so that we can deploy these development environments, assign them to developers. Developers can go in there. They have the ability to spin up like 10 AMIs at any given time, or spin down 10 AMIs, and we put some constrictions around that so that We can centralize resources from outbound for internet, so I can protect, information getting out, or, an attack of some sort, that we can minimize that by centralizing resources and access into that environment, and really lock down and give them the tool sets that they need in a secure manner and automate that. So we've seen customers that have taken that and now have pushed that out and are running these environments and providing these environments for their development teams. So this kind of shows an example of using our device so that we can, automate that delivery of these development environments. From there, customers, as they look at applications, as I said, that maturation process of what we've seen our customers go through started out with lots of applications and doing as much as they can with as few devices as they can, and putting as many applications into a VPC and building them that way. And what customers have found is, as they work through that development cycle, how do I update my applications? If I have multiple applications, is there a possibility that I can deploy code for one application that could have an impact on the entire VPC and bring down all of my applications? And so we're seeing this change now where customers, as you look at that scale-out mentality of public cloud, how do I now deploy so that I can have some consistency with my applications? I can have, I'm not going to have those issues with bad code creating problems for me. So we've seen customers start to take and simplify their environments, move them to a single VPC for a service. So almost like a container, but using the VPC as the container to be able to develop an application and make that singularly into a single VPC, so that from there, now I can use automation tool sets, and I can now deliver that application across multiple regions and use a global load balancer like Route 53 to be able to do that global load balancing across all of these different VPCs to give me the scale that I need, to give me the performance that I need, and to give me the high availability that I need, and make that easy. That lends itself into that immutable architecture. And how many of you have heard the term immutable architecture? So for those of you that haven't heard about what immutable architecture is, I think that there's always a little bit of a difference to how people will define that. But as I talk about immutable architecture, what I'm talking about is more of that process of, if I'm able to take and use these building blocks, this small, reusable, automated piece. When I develop new code and I'm using global load balancing and distributing this, I have the ability to keep my production environment static, where I'm not going to do patches in that environment. I'm not going to bring new code into that environment. If I'm going to do any of that stuff, it comes into a pre-production environment where we can then test it and make sure everything is good. And then it ends up being a DNS name resolution change to be able to move to my pre-production environments, and my production environments then get destroyed. So it's this maturation process of how you test and bring applications up without having to manage the day-to-day stuff of patches and all of that stuff. Anything that needs to be patched, new codes, all that comes into a completely separate VPC that is stood up beside that for pre-production testing before it then works its way in. So as we talk about that CICD from a continuous integration perspective, to be able to, as you write that code, build those unit tests and do a lot of that testing and automate those testing processes to help keep your code and keep your application running to the best that it's possible. So that's one of the things that we see a lot of customers looking to move to, and breaking away from that process of putting lots of things into a single VPC. So I want to walk you through, we've built a little demo where we're going to build an architecture like this, where we're going to use our firewall and deploy our firewall from an automated, from a Terraform template. We're going to, so an AMI from the marketplace. We're going to deploy web servers, and we're going to build security policies so that we can use Terraform to stand up the VPC. We can use Terraform to build our entire environment from a routing, subnets, and then we'll use Ansible specifically to, on the back end of that, come in and actually configure our firewalls. So just a real quick demo that we can spend so that we can kind of show that process of how we deliver an application, how we can take, because as he said, that process of working with the different siloed pieces to an organization. So, security, as he said, the toughest thing about security, and we're a security company, is security is very static. It has to be very static. Because if you get out of that, then that's when you lose control and bad things happen. So how do you take that static environment and work within a dynamic environment of what your developers are looking for, what they need, and also incorporating in the networking team? I can't tell you the number of times I've sat with customers and everybody's fighting over who's going to manage the load balancers in their environment. Should that be the cloud team, or who should that be? And so now we have the ability to bring all those people together to be able to talk through this from an automation perspective. What do we need from a networking? What are those rule sets that you've developed from a networking perspective? And then take what you need from a security perspective, automate that. As we said, security as code. So now if I'm delivering infrastructure as code, I can also tap onto that and bring security as code in. How do I do that? As we start talking about the automated and programmatic approach, I have the ability to be able to now, if I'm building these AMIs, I'm building these infrastructures, I can actually put in tags, so I can use tags. For us, we're able to now query the API, pull the tags back. We're able to now use that in a security policy that is dynamically populated with what we call a dynamic address group, where within that policy now, the IP addresses that are associated with the tags get associated with the dynamic objects that are now in policy. So when any device comes up, a new device is spun up, a new environment is spun up, we read those tags from the APIs that we continually update, and they're now associated with policy. And so as we look at that, that gives us an automated approach to how we can now incorporate security in those standards into the automation, so that when we spin up these templates, the security is also deployed with them. And what I'll see customers do is they write default rules where if I've defined all of my applications, all of my use cases, I've automated all of those use cases and tool sets, if something comes up that doesn't match any of those, then I've got rule sets in my firewall to be able to quarantine and close those off, so that that whole shadow IT thing, if somebody is doing something on their own that you don't know about, you can protect yourself. So that programmatic approach to incorporating security as code for deployment becomes that happy medium to work with and allow your development teams to have that dynamic environment, or provide the environment that you need, but also meeting the requirements for your security team, for your SOCs. So, as I said before, we're going to be using Terraform and Ansible in this script. When we do this, it's we've created a Docker doc that we're using, where we'll instantiate the doc, and then from within the doc, we'll have the tool sets, so that from there we can actually deploy out the architecture utilizing Terraform. So you don't have to do that. It's something that we did, and it's a part of this demo, but you don't have to do that. You can have Terraform on your machine and just use the Terraform and the scripts that you're writing for the Terraform platform, as well as our Ansible YAML playbooks. So with that, I'll move over and show you this video.
So we are using a Docker just as a packaging mechanism for this demo. So even if you want to down the line try this on your own, which you can, we'll share some links for it. If you just download Docker, it's going to have all the tools, so you don't have to mess up your machine if that's what would happen, right? And just use all the tools. It's just a set of the tools which you can download on your own too.
Okay. So from here, what we're doing is displaying the docs that we have, and we're going to use Docker, and we're actually going to run one of our docs that we have, so one of our containers. We're going to map the drives that have the important files that we need. So our templates, our Ansible playbooks, our environmental variables files, so that we can use them within our template. So right now, we're spinning that up, and we're creating the container, spinning up the container. So once we have that container spun up, here in a second, you'll see we'll move to actually hitting the command line of the actual container and start the process of installing some of the tool sets that we'll need. We've built an automated script for that. And so you'll see the pan-_install. That helps us so that we can deploy the libraries that he was talking about, that we've deployed to help make this process easier when utilizing our devices. So once we do that, you'll see we'll run through, we'll install Terraform and Ansible, and then we'll actually pull the Palo Alto Terraform and Ansible repositories so that they're available to the dock.
And we could have automated this too, but
yeah,
then
we definitely could have automated.
Then it looked too easy.
So from there, now what we're going to do is we're actually going to access what we call our one-click. And by the way, these templates are available on our GitHub repository, so you can actually take one of these sample templates and adapt them. So we're calling that template. We're going to move over our credentials file. And then once we do that, once the credentials file is moved over, we're going to do an apply to that.
And you should really
Terraform apply. So that will actually kick off the process of going out and starting the install. So in this file, we can automate the variables, but from here, we're going to actually show where we're going to add in some of the variables here of, what keys we're going to use, what regions we're going to be in, and then we'll go ahead and spin this up in that environment. So I think this is using US East 1. So now our deployment has started. Once the infrastructure gets built, our firewall has a process where we can bootstrap our firewall. We use S3 for bootstrap, so we have the ability where we can put new revs of our code, and we can completely automate the process. All of our files for our firewalls are built on XML files, which makes it easy to be able to throw that into an S3 bucket so it can be called by our firewall and come up with that config. So after the firewall spin up, they're going to go through that bootstrap process once we associate the right AMI, and we're going to wait for the firewall to come up, and it will get its configuration, a base configuration, I should say, because you don't want to put some of those security pieces out in an S3 bucket. So we're actually going to utilize Ansible to put some of those more detailed pieces in. But we'll wait for the actual firewalls to come up. Once they come up, we'll see the Ansible script is embedded into the Terraform template, so it will call the YAML file, and from that YAML file, it will actually run and hit the libraries and configure our firewall. And from there, once that all comes up, now as you can see, we've gone through and just did, pulled up the website so that you can see the text from the website, our web server response. So we've actually taken and built and configured an entire environment and had the response from the web server come up that we've secured with policy. So these are the things that I'm talking about that with what we're doing with our tool sets gives us the capabilities to be able to automate these things and make them very easy.
And just as a disclaimer, we don't suggest that you put your credentials in a file.
No. No.
But it helps fit a demo. Put them in a vault or somewhere else, but not in a file.
Yeah. So let me switch that back off. How do I go back to the slides? Thank you. So one of the things that I want to talk about, as we kind of start to wrap this up a little bit and take some questions from you guys, is we are trying to help our customers and our partners by developing templates. So as I said, we have our live site that you can actually go out to our live site, and a lot of these templates are made available. We have some that are supported by our TAC. We have others that are community built so that you guys can use these as a basis to be able to start automating the different environments and deploying our firewalls and our security services. We also have a GitHub repository that is github.com/Palo Alto Networks, where, again, we have a lot of tool sets there to help with the automation pieces to your environments. So I highly recommend that you take a look at these. We've got some really good templates where we've deployed, the load balancer sandwich as it's called, and we've, Lambda functions and how we can manage and track state within the load balancers. We've got sample whole architectures like what we just said, the one-click architecture, where we've got deployment guides as well as scripting so that you can deploy those. It makes it really easy and a one-place stop to be able to go out and find some of that stuff. So with that, we'll open it up, and we're happy to answer any questions that you may have around automation and our tool sets. Yeah.
So we're using Wrapup. We've been using it for a while. We started off with and that just didn't work out so good. We actually just purchased it. So you're suggesting building Terraform scripts to build the environment from step one all the way through. The VPC, the IGW, the security groups, the whole shebang, right? How many customers do you see out there that have that type of automation fully functional?
So can I just, first part of your question. So we're not suggesting Terraform. We saw that Terraform has a very good adoption. I think what you're going to do is depends on your DevOps culture. You're going to have a DevOps who like Terraform. You're going to have DevOps who like Ansible. You'll have DevOps who come from, this or the other space. So I would highly suggest that you follow your DevOps if you already built a team. Otherwise, it's going to be a really uphill battle. So now, you said as far as the Terraform goes, how many customers we see that build Terraforms? Well, pretty much every single conversation I had with any cloud customer, born-in cloud customer, used Terraform 90% of the times and probably Ansible 10% of the times, and really nothing else behind it.
Well, we're using it 90% of the time, but from VPC stand-up through the whole entire account, do you see a lot of customers doing that?
So the way what I see is that they use Terraform to build topologies, and then use something like Ansible or maybe SaltStack or Puppet, if you support that, to do configuration management and incremental changes. So day 0 would be Terraform. Day 1 and day N would be like just the configuration changes with one of these other tools.
And as far as customers, what I'm saying, like I talked about earlier, that maturation process, a lot of customers may not be at that point where they're ready to have full automation yet because they're still learning. And we see some customers that have gotten to that point where they've taken and seen the value of what the automation brings for them, and they're working toward that. So, we've got customers on the entire spectrum of that right now.
Yeah.
Your networks and how they talk together. What's the difference between that and something like Terraform? Or I'm trying to figure out what your blog. You can create those private networks with something like Docker Swarm, and what does Terraform?
Yeah, so it's a good question. They're very different, right? Docker Swarm is used for the orchestration of the Dockers, and it's really the scheduling system which allows you to schedule your Docker containers, right? So now Terraform has a provider for Docker Swarm that you can use to automate your Docker Swarm deployments. Does it make sense? So while Docker Swarm, and we can have conversation after this if you want to have detailed conversation, but Docker Swarm will allow you to obviously schedule your containers. You can use Terraform to deploy Docker Swarm, and then to use Terraform as the initiator to deploy your containers. So they're a little bit different, right? That makes sense. Yeah.
Any other questions? Okay. Well, we'll be here for a few minutes. If you have any questions and you want to talk to us, we're happy to hang around for a bit and answer some questions. We had a little bit of time left. So thank you for coming out. I hope this was informative for you. And
enjoy the rest of the show.
Yeah.
Yep.
Thanks.